Welcome back for the final lecture of this week. So for relation extraction, we've talked about handbuild patterns, we've talked about bootstrapping approaches and also supervised approaches. So in this lecture, we will talk about a very interesting approach that uses the previous two approaches nicely. It's called distance supervision, and we will see what is the basic idea. Hoping you will find it very interesting. So what is the idea? So we start with the hypothesis that is similar to what we were using also in bootstrapping. So what is the hypothesis? If there are two entities that are connected by a particular relation, whatever sentence in the corpus they occur in, that sentence conveys that relation. Okay? That is the hypothesis. That's what this model is built on. That I have two entities, I know there is a relation between them. If I find a sentence in the corpus where these two entities are there, I can think of, okay, these are connected by that relation only. So yeah, it's likely to express that relation. So what is the key idea here? So we are trying to make use of both bootstrapping and supervised ideas. So that is, so here what we do, we start by using a database where you already have lot of instances of a particular relation. So lot of seed tuples are there. So you use a database of relations to get lots of training examples. Instead of handcrafting a few seed tuples that you do in bootstrapping you take only very few seed tuples and start doing some iterative method. And instead of using hand label corpus that you do in the case of supervised approach. So you do not do either of this, but you start with a database that contains lot of such relation examples. So what is the approach? So you have a database where you know, okay, what are the entities that are connected by different relations. Now you automatically grab various entity pairs from this database, and you have a lot of unannotated data. You go through that corpus and find out wherever these entities occur. You try to extract various features from there. You do not take simple patterns, you gather now. You take them as the labeled sentences, extract features from that. So you grab sentences containing these entities from a corpus, extract lots of noisy features from the sentences. These can be lexical features, syntactic features, name entity tags. This is what you are doing in supervised approach. Okay, but now you are doing that without any hand labeling, and then combine this in a classifier. Okay, so if we try to understand that from a block diagram, what we will do? So we will have a database that will contain, okay, entity 1, entity 2 and relation 1, entity 1 prime, entity 2 prime, relation 2 and so on. So this is what you will have in the database. Then you will have a lot of corpus. There are a lot of sentences. So what you will do? You will use the hypothesis to say that wherever these entities are found in this corpus, they are connected by this relation rel1. So here you have the entity 1, entity 2, entity 1, entity 2, entity 1, entity 2 in these sentences. Now you start assuming that this is your labeled data set. So now you know this is your labeled data set. So you will say, okay, you will label it by label 1 or by this hypothesis. This is relation 1, this is relation 1. This is your labeled data set. Now you do exactly what you do using supervised approach. Okay, so we will try to use, okay, this is my relations. Now I will extract features from here. Sorry. So that is what words come before, what words come after, what is the sparse tree, everything you can use. So use these features to build a classifier. And that classifier, when it runs over new sentences, can give you labels. These two entities are connected by this relation and so on. So what is, so now also we can see how it is different from bootstrapping. In bootstrapping, you start with only a few seeds. Now you go to the corpus. Here you do not take the features in bootstrapping, you only take the patterns, simple patterns. Okay, and we are not as good as using the features in a classifier. And what you do in the case of supervised approach? In supervised approach, this has to be done manually. You have to manually tag each sentence with the relation, entities with the relation, and this you are avoiding because by using database. Okay, so the database is not there in the case of supervised approach. So you directly go to the corpus, you start labeling, and use those labels to create your classifier. So what you are seeing, you are trying to combine bootstrapping and supervised in a nice way such that you are avoiding the problems with each of these. You are avoiding the problem with bootstrapping, that is no probabilistic interpretation, you do not know whether it will do good or bad, there are only a few seed tuples, by taking a lot of examples and doing with features instead of patterns. And you are avoiding problem with supervised approaches by avoiding your labeling task and taking from database the labels. So that's how you combine both of these approaches together. Now so this has advantage of supervised approach by leveraging rich handcrafted knowledge, and you can use rich features, and also of the unsupervised approach because you can leverage on unlimited amount of text data. It may not have been labeled, then also you can use it in this approach. And you can use a lot of different weak features, so syntactic features, lexical features, and so on. And it will not be sensitive to the training corpus. So it will work on whatever corpus you're trying to use it on. So let's take an example of finding hypernyms via this distance supervision idea. So what we will do, so what is a database which will contain the hypernym pairs, and you can see what is a database that contains super concept, subconcept in a nice machine readable manner. So I will try to use that database to find out more hypernyms. So let's take an example by a single hypernym. So suppose one example is Shakespeare an author. Shakespeare is an author. So what I will do, similar to bootstrapping, I will go through my corpus and find out where all these entities occur together in a sentence. So suppose I find out some sentences like this: consider authors like Shakespeare, some authors including Shakespeare, Shakespeare was the author of several, Shakespeare author of the Tempest, and so on. So these are various sentences where I am finding these entities, and I will immediately label them with the relation of hypernym, that entity 1 Shakespeare here related to entity 2 author by this relation of hypernym. So this labeling can be done automatically now because I have these relations and the hypothesis. Now one problem here might be that there are some noisy examples like the author of Shakespeare in Love, authors at the Shakespeare Festival. So can you see why this is noisy? So author and Shakespeare, both words are occurring together, but they are not occurring in the relation of hypernym. You see, I am talking about here the author of a book Shakespeare in Love. Okay, it's not talking about Shakespeare being an author. Similarly here, some authors at a festival. Okay, they are not talking about Shakespeare being an author. So what will happen? Suppose you take it as your pattern, authors of Shakespeare or authors at the Shakespeare Festival. If you take this as your pattern, if you try to extract new entities, they will not be correct. Okay, so think about a pair of words that occur with this relation or this pattern. Okay, so this can be someone was at somewhere. So it does not say that this is subconcept superconcept relation. No. So this is a noisy example. Now how will my distance supervision handle these noisy examples? So in the case of bootstrapping, there is no easy way to handle these examples, but here what I will do, because I have many seed pairs for this relation, so this noisy example will occur in maybe 1 or 2 cases, but they will not occur in most of the cases. Okay, and that's what I will make use of. So they will occur maybe 1 or 2 hypernym pairs, but they are not occurring with many other pairs. And if I take random pairs, they might occur with them. So that's why these noisy examples will not deteriorate the performance of my system. So how do I learn the hypernym patterns? I take corpus sentence like doubly heavy hydrogen atom called deuterium, okay, and I have the entities like various nouns like atom, deuterium, etc. So if I take, so here what was done, 6 million sentences were taken from Newswire, and 752,311 pairs were found of entities, noun pairs. So this is starting from the data. So you have a lot of data. From there you are finding noun pairs, and you are saying that you have 750,000 noun pairs. Now to use distance supervision, you have to see, okay, some of these noun pairs are already involved in hypernym relation. So you can use WordNet, find out how many of these are having this relation. So from there you find out, okay, 14,000 roughly are having this relation, and remaining 737,000 do not have this relation. So immediately you have the positive examples and negative examples from the data. So wherever one of these 15,000 entities occur, you will say, okay, these are connected by the relation of hypernym, and wherever these entities occur, there is no hypernym relation between these entities. And this you can use to build your classifier and extract various features. So you parse the sentence, extract patterns, build various features, and train classifier on these patterns. And so suppose, so in this experiment, they ran logistic regression classifier with 70,000 different features that were considered using patterns and everything else. So now patterns are, so in this approach, what the patterns that they used were based on a specific dependency parse. It's called minipar parser. So this will tell you how you can find out nice patterns and use them as your features also. And so what is the idea of using minipar for constructing your patterns as features? So suppose you have the sentence, Shakespeare was the author of several plays, and you want to find out a feature between the two entities, Shakespeare and author. Okay, you want to find a feature between these two entities. So what you will do, you will run this parse, this minipar parser, and you will get the parse of this sentence. So you have this parse of the sentence. So you have the lemmas here, Shakespeare, author, the, of, and be, and they are connected by various relations. Different words are connected. Now you want to extract a relation between, or a pattern that connects Shakespeare and author. So what is the idea? You will abstract over the words that you want to connect, because you want to find out what are the other words that are connected by the same sort of pattern. So you will extract over Shakespeare and author, call them X and Y. Okay. So you are starting from Shakespeare. So you will say what is the path that connects the two, and you are going in the opposite direction here. So you are saying what is this path? What is the first dependency relation that connects Shakespeare? And in minipar, what happens? You write down what is the part of speech of the first word, relation, and part of speech of the next word. That's how the relations are labeled. The dependency relations are labeled. So here Shakespeare is a noun, be is a verb, and the relation is subject. And you are going in the opposite direction, so you are having a minus. So you are denoting this relation by minus, noun, subject, and VB. VB is the part of speech tag for B. Then you will take the intermediate words. So you will take the word be here. Then you have another path. So you will again take VBE, predicate, and the noun. And you will stop here because you want to connect Shakespeare and author. So by this simple approach, you can try to find out the patterns between any two possible words from the dependency parse. So what they did, they found out all the possible patterns between different words in the corpus, and so there were 70k different patterns that they use as features for training their dependency graph, not dependency graph, but their logistic regression, for finding out if two words have a relation of hypernym. Now and they did some more tricks, like as we discussed, original nouns in the noun pair were removed to create a more general pattern, and each dependency path is presented as an ordered list of dependency tuples that we were seeing. and sometimes they have some satellite links like search and edge. So what is found when you are building patterns, function words are very important to the patterns, but the content words are not so important. So whenever you have a pattern where you have a word like search, there is a noun phrase, edge, noun phrase. So what you will do, you will retain the function words, but the noun phrases you will put them as noun phrases instead of the word. So instead of saying search red algae edge gallidium, you will say search np edge np. Okay, and these search and edge can remain as it is, because these function words are very helpful in describing your pattern, and this is a nice trick that you can use for building your patterns. So abstract over the content words and retain the function words. Even content words, you might take some content words that are having very high frequency, because then you might find them more often. But if something is not having high frequency, there is no point in keeping the word as it is. It's better to abstract it as either as part of speech tag or the particular phrase and so on. And this helps a lot in building these patterns. And this you can use as your features or whatever. So now, once they did that, so in this figure, what you are seeing, individual feature analysis. So if you take only one feature at a time, what is the precision recall that you get on your data? And you are having certain, so there are like 70k different features, and you are seeing most of the features had very poor precision recall independently. But there are some features that stood out, that were giving very high precision recall. And when they analyzed, they found something very interesting. So these are the features that were having nice recall and precision, and these are the features: x and or other y such as x, such y as x, y including x, y especially x. Now do you remember these features? Okay, so when we talked about the patterns that Hurst built manually, he was using these features. So these features he manually identified. In this approach, we never gave these features manually, but the algorithm was able to identify these features automatically. What were some other features? Like y like x, y called x, x is y, x a y. So these were also some other features that Hurst did not find, but algorithm was finding. And if you show them to various linguists or various people, they will say, oh yes, these features make sense for this particular task. So this was very, very interesting about this approach. So now this was just for a single relation hypernym, but suppose I want to do that for many different relations at the same, so together, I want to train them together. How will I do that? So that's where in 2009, this was this paper by Jarofsky's group, distance supervision for relation extraction without labeled data. Okay, so what they did, in place of their corpus, they used Wikipedia. So that had at the time 1.8 million articles and 25.7 million sentences. That was their unlabeled data set. What was their database containing the relations? They used Freebase. Now Freebase is a very large repository of various entity pairs and the relations. So that time it contained 102 relations, 940,000 entities and 1.8 million instances. That many different pairs of entities are present with their labeled relations. Now how does the relations look like in Freebase? So you will have a relation name. So in the category of people, there is a person and nationality. That's how you need to read it. There are 281,000 different relations, and one example, John Dugard is the person with nationality South Africa. Similarly, location contains Belgium contains New Zealand. Person profession, Dusa Macduff, age mathematician. Person place of birth, Edwin Hubble, born in Marshfield. So like that, this Freebase contains all these relations and what are the entities that are connected by this relation. So now, so what is their task? Using this whole data set, try to come up with the algorithm classifier such that you can populate this database. So you can find out new and new entity pairs that are connected by relations. So what is the idea? What they do? So here is a simple illustration. So you have this corpus text, okay, like Wikipedia. So there are various sentences that are here. Then you have your Freebase that contains the relation and the entities that are connected by the relation. like founder, Bill Gates founded Microsoft, Larry Page founded Google, Bill Gates attended Harvard. So various relations and the entities. Now how do you make use of both of these? You will take the you will either take the relations here and go through the corpus and find out wherever they occur together in the single sentence. So you will say, okay, Bill Gates and Microsoft occur together in this sentence. So you will say, okay, let me say Bill Gates and Microsoft are the entity pairs. They occur in the sentence. So I give a label as founder. And then I extract various features. Here for simplicity, we are only showing one simple pattern, X founded Y, but in general you can think of any other feature, like what is the next word to Y is in, and what word occurs between X and Y, is X starting the sentence. So like that you can have many different features. So you are giving a very simple feature here, X founded Y as the pattern. So that's what you are doing for each entity pair. You are going to the corpus, selecting sentences where they occur, using the hypothesis, okay, they might be connected by the same relation, labeling the relation and extracting features. Another sentence it occurs, so you will extract features, X founder of Y. Now suppose you go to Bill Gates Harvard, you have this sentence and you will extract the feature, okay, X attended by relation college attended. Similarly here, Larry Page Google, so founder Y was founded by X. So by different sentences you will try to you will be able to get different sort of features and different sort of patterns. Now these are all positive examples of various relations. You might also have to get some negative examples, that these two entities are never connected by any relation. Now this is interesting, that how do you construct negative examples in this distance supervision approach. And the idea is also very interesting, that you have your database, you know what entities are connected, but from your database also sample some pair of entities that are not connected by any relation. So once you sample these entities, find out the sentences in the corpus where these are appearing together and label this as no relation, okay, because we know there is no relation in the free base among these entities, and this will generate your negative data. So this is your positive data, and then you will get some negative data also. So you can't train a classifier with only positive data, so you need some negative trained data. So what you do, sample 1% of unrelated pairs of entities, okay, 1%, because otherwise there will be too much negative data. So you do not want to make a classifier where it is more biased towards the negative examples. So you take some sample, you undersample the negative cases, and here is how you will do that. So suppose you find out in your corpus, in your database, there is no relation between Larry Page and Microsoft. So you will find out the sentence like Larry Page took a swipe at Microsoft, and you will say, okay, with this feature the label is no relation, X took a swipe at Y, no relation. Here Harvard invited Larry Page to something, so Y invited X, no relation, and so on. You will do for all these pairs of entities. So you have now got, and so yeah, what will happen at the test time? Test time you will have the corpus text, so you will have the sentence here, you will find out the entities, and then you will pass it through your classifier to find out is there a relation between these two. So you have the feature like X founded Y for the entities, but you do not know the label in the test set. So we will try to use your classifier to find out with this feature is there a relation between them, and if so, what is the relation, and you will say, okay, similarly here, Y was founded by X, what will be the label, X attended Y, what will be the label, and the classifier will be able to tell, okay, this will be college attended, this will be founder of, and so on. So yeah, in a single figure, if you want to see, so you will have some positive training data, you will have some negative training data, you will use these to learn your logistic regression, and we are multi-class, where no relation is also a class, and you have many different relations. At test time, what will happen? For each sentence, you will take the entity pairs, you will try to identify the features, and you will feed it to your classifier to find out with these features what is the relation between these two entities. Okay, so here suppose the predictions are Henry Ford and Ford Motor Company, the label is founder, Steve Jobs and Reed College, the label is college attended. Now, what are the kind of features you can use? So, although we have talked about the features, but you can use features like, so they should tell how the two entities are related in the sentence. So, you can use lexical features in terms of only the words, you can use syntactic features in terms of what their connections, you can use dependency paths like the example we discussed, you can use gadgeteers, named entities, lot of different things that you can make use of. So, lexical features can be like what are the sequence of words between the two entities, part of the speech tags of these words, a window of keywords to the left of entity 1, they are part of speech tags, a window of keywords to the right of entity 2, they are part of speech tags. And you can also combine these features. I will take part of speech tag of the previous word and the part of speech tag of the next word. I can also try to combine these features and generate various conjunctive features, and then use a lot of syntactic features. And once you identify these features, use that to train your regression classifier and get the output. So that's where we will end this week. So we talked about some interesting application on entity linking and information extraction, relation extraction, and we saw that there are nice ways in which you can make use of lot of data that is available on the web and put it in a more usable manner. So entity linking, so that given an entity what particular concept it corresponds to in a database. In information extraction, you can find out given entities what is the relation in which they are, what is the relation that connects these two entities, and you can populate a knowledge base using that. And these are some of the very nice and important applications in text mining. So with that we end this week, and I'll then see you the next week.